Hello, 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 everyone. Welcome back to once again a JIT CAD CAM exclusive free support Friday, where we do our best to help each and every one of you out there that may or may not have support through us here directly at JIT CAD CAM to get the help that you need or to answer the questions that you may have, or even help you conquer some problems and workflow issues inside of Autodesk Fusion 360. So I'm going to give this a few minutes. As you guys know, if you've been here before, I'm seeing the notifications popped up that I am live now. Looks like my audio is good. You should be able to see me. If you guys can't see me for some reason or the audio is terrible, feel free to let me know in chat. I'm going to kick this off as we always do. Is if you guys see something today that you like or you learn something new, by all means, we do have multiple ways to contribute through likes, subscribes, buying me a beer, as well as additional things. And as you guys are going to see, I'm going to crack open a lovely energy drink, Orange Dreamsicle, or Orange Cream, I should say, one of my favorites. But let's get this party started. Now, I am going to warn you guys, I have nothing in the shoot today to go ahead and kick off and get things going with. So I'm going to need suggestions from you as well. Pre-warning here, we're only going to run this for about 45 minutes today because I will be jumping over to the Too Tall Toby CAD vs. CAD semifinals as none other than the co-host once again. So let me go ahead and get back over to just me here. I am failing to see any stats on my side, guys. Let me know if you're out there, if you guys can see me all right. I'm going to go ahead and pull this up. Looks like we have 7 people in here at the moment. None of you guys in chat. Tell me, is chat working? Chat not working? You guys too busy submitting ideas? Awesome. There we go. We already have our first question. Maybe I need to kick this off this way right off the go. Bogdan, great to see you once again. At CAD is life. How do I get rid of jerky motion on simulation on Haas UMC? I was running a deburr toolpath and all the linking moves were jerky. I changed it to always use hide feed. Now, my question real quick, CAD, are you talking about simulation in Fusion or physical running at the machine? I'm going to go ahead and start sharing my screen and I can kick this off with a couple of parts. So for the sake of what's being asked right now, we're going to go ahead and go with something simple. I'm just going to create a box because, well, if you just do a box, you can tend to save yourself some headaches. And let's go ahead and pivot over. So the physical machine is jerky. Awesome. So let's go ahead and jump over to manufacture. I'm going to do my setup here. Pretty sure I have a Haas UMC machine out there somewhere. Give me a quick second. Again, I'm actually, you know what? The TR160 is going to work as well because it's going to be a couple of things and I'll show you guys where I would point you. Oh, in typical fashion, you got to go ahead and save your file prior to doing any of this. And let's get this thrown in the proper area where we can always delete it later, right? So again, getting up to the free support Friday, episode 41. It's crazy to know that I have done 41 Fridays since I've started tracking it this way for free support. But we're going to run that one more time. Do our setup, milling machine. Let's get this put on our Haas BF3 in this case. And again, it's not going to make a difference. It's all going to be relatively the same on the Autodesk side, as well as a couple of tricks I'll show you guys. But as you guys can see here, I now have my part. And from that, let's go ahead and do our 3D deburr toolpath. And we're going to have fun with this because this is going to be a full 5-axis toolpath nonetheless. Go ahead and get our ball end mill here. Again, full 5. We're going to go ahead and no boundary. Probably going to be easier just to say exclude the bottom edges here. And let's go ahead and make sure that we have an edge width. So I'm going to get a toolpath on our part, then we're going to simulate it out, make sure everything looks good before we jump over to looking at what could be the machine cause. So outside of that, again, if anybody else has any questions at any time, feel free to throw them in chat. You're welcome to ask just about anything. I'm going to go ahead and simulate this now. Now, I always like to simulate with normal simulate before I jump to machine simulation, ever since Autodesk did add the fast GPU simulation, right? So as you guys are seeing here, as I'm actually clicking and dragging my mouse on my screen, and making sure that I'm getting anything and everything I want done. Now, as some of you may or may not notice, I am getting jerkiness on my side when it comes to simulating this. And a lot of this could be done based on the fact that I do have my accuracy cranked all the way up. So we do tell most people if you turn your accuracy down, you should see an improvement. Again, the actual speed at which your simulation is running will also make a pretty big difference. Again, you guys can see it's smoothed out quite a bit by increasing my speed. Again, we're going to go ahead and exit simulation, and I'm going to jump over to the simulate with machine side of things. So again, we're going to give this a second to load. Now that we've loaded up that actual part file, we can go ahead and simulate once again. So as you guys can see here, it is quite jerky on my side. And the reason for it being jerky is due to the fact that I have all of my settings cranked to the max right now, which will make a huge difference. And the reason why it will make a huge difference is if you look at this rotary on my table, and we're going to open this file up in a second, but there is a lot, and I mean a lot of components and parts and pieces that, again, simulation is not only having to run the toolpath, but it is also having to physically move this model and manipulate it. So right out the hole, what I tell most people, I prefer the comparison tool, and I never really run it as high as some people think. I can also adjust my tolerance quite a bit here to increase and make, as you can see, smooth motions happen much better at the end of the day. So now when we start to talk about the physical machine, if you're getting jerky motions as CAD is Life was talking about, let me run back through here real quick, is the linking moves were jerky. And then he utilized always use high feed. Well, what does that mean? So if I look at my G code here real quick, again, point out to Autodesk, hey, there's a bug when I open NC code that it minimizes my window. But if we look at the G code for this part file right now, as you guys can see, I'm actually going to drag my mouse a little bit, but everything based on motion right now is G00, right? So again, rapid, and then we hit our first feed rate down here of 650, and then that 650 down into our part eventually hits 13 inches per minute, which is probably our feed rate or our ramp feed rate, and we continue to move around our part. Now, if I was to swap that out, I can go into my toolpath, and as you can see, I can swap out preserve rapids for always use high feed. Now, I'm going to set my high feed a little obnoxious at 1000. This will allow us to see it very quickly in the G code. Again, this is ways, if you guys didn't know, that you could pick up quite a bit of cycle time on your machine, because most machines, the rapids only tend to be at 100 to 200 inches per minute. So again, as you guys can see, we're going to get our G code pulled up. And just like that, again, we have our rapid motion. And getting further down, you now see we're at 650. And we should see that feed rate 1000 right here, getting down into that machine and machining everything out. So again, we are now utilizing some different feed rates. However, I would like you guys to see that these are all based on program feed rate. And by program feed rates, if I get to this line right here, we hit that feed rate of 40, 39 and some change, is all of my rotary moves are having to be calculated at the controller, right? So again, is instead of utilizing possibly a program feed rate, which works really good for linear motion, we can actually go in and edit our machine. Now, what this can do for your controller is it could alleviate the translation at the controller, allowing it to actually process code a little faster and smoother. So again, as if I go into my multi-axis and I go to my drop down, as you can see, you have multiple different options here. Now, degrees per minute combined will use a combination of program feed rate and degrees per minute, or you can force basically standard degrees per minute. So again, based on your use case, we always tell people play around with them a little bit. There's a really old video on our Facebook page of a rotary toolpath on a Fadal machine. And if you notice, it actually runs really, really terribly slow. And that's because it was stuck on program feed rate, not the actual, degrees per minute as most machines will need. Now, a few other things I would ask, CAD is life. I would need to know how fast are you trying to move that tool as well, because that will make quite a big difference when we get down into your G code. Is are you running at a specific feed rate that exceeds how fast your rotaries can move, things of that nature. But right here, as you guys can see, we jumped all the way down here. As you're seeing, I'm running at a feed rate of almost 600. Now, and the reason why we're seeing that 600 down here is because we're getting our A and C tilts, where up above, we were still only X, Y, Z. So once we started adding our rotaries in, we're now getting those additional rotary moves. So I see Ash Design out there. Ash Design, I assume, is the same person as CAD is life. So as you guys are seeing, again, the ability to tell your controller to use degrees per minute versus inches, or degrees per minute versus basically inches per minute, this could help remedy the situation. Again, Ash, that might be some of the cures to what you have going on. I would also need to know a little bit more detail about what it is, because again, if you told me you have a Haas UMC, that is not an SS machine. There's so many factors that could be limiting how that machine is moving. Again, I would ask the question, do you have program look ahead, right? These are all things that would make a pretty big difference. Now, you guys have never seen the video on my YouTube channel. We actually did one where another option that might help in this situation is upon post-processing, especially on the Haas machines, most of the posts have the ability to use things like G187. Now, what G187 is actually going to control smoothing on the controller side. Now, a Haas uses a relatively simple system. It's basically level 1, 2, and 3. You get into Fadal, or not Fadals, but Fanuc machines. I've seen anywhere from, 10 to 15. Mitsubishi machines use a 2-step process where you kind of have 5 levels, and then each one of those 5 levels has 3 additional settings. So you could have level 1, tier 1, tier 2, tier 3. Again, all utilized in a lot of different ways. Now, this is probably a really good talking point here. So I see Ash out there, as he's saying, is 100%. So it's an old Haas original UMC. I would attribute his problems to one that probably does not have look ahead, which does have, actually, he has the classic control. So I would actually advise getting either a trial of look ahead, which is referred to as high-speed machining also, that would be a good place to start. Now, we could possibly do a few more things here. Like I said, we could actually swap out on your machine instead of utilizing the Haas next-gen control. I don't know how many of you guys know this, is depending on who set up your machine and what post-processor is associated. Get back into the machine side of things. Looking at the post-processor, sometimes you guys will notice down here where it says post-properties, there's an option to pick pre-NGC, post-NGC. Again, if you're using machine definition for a lathe, sometimes you do have additional options that show up here. Now, if you guys want, I can always happy to make a video to show you how to move your post-properties into this window so that people on the shop floor can't change them. So, what's the odds? It's perfectly smooth when performing a cutting move. It's only the linking move. I think at the end of the day, if we were going to really start to look at the linking moves themselves, now, I'm not sure if this will show us, but it would be the tolerancing of the linking moves at the end of the day. So if, again, we go ahead and say all tool paths, and I do have show points on. Now, as you guys can see, that's a pretty big arced move there. And again, I think in some ways, it could be as easy as, you're trying to travel too far too fast could be jerky, or it's the look ahead of the machine. But let's get back to what I was talking about in the post menu. So again, I go to post process. By default, if you were to use G187 here and set it to automatic, this also works on other post processors. There is what is called the automatic function. Now, the automatic function at the end of the day, as you guys are going to know here, we're going to have to go in and grab one of these posts that I can actually edit, is I'm now realizing my chat window sits right in the way for you guys to see this. But what I'm looking for is basically the good old Control F. And if I type in 187, again, this is what it's called in the post, you're going to notice that I found the area where we can set that. Now, where it says use smoothing, again, Control F allows me to automatically copy and paste and then jump down. Now, this is where everything gets a little tricky. And if you guys don't feel comfortable with this, I understand. This is why we are an Autodesk reseller or an Autodesk partner, as it's called. We're here to help you guys with making these changes. Feel free to submit some support tickets on that. But as you're going to see, is we have different options for setting our smoothing. Now, you do have what's called smoothing levels. Again, we could set different levels depending on your machine. But there is also, if I can find it here, unless they stole it away from me, is there's the ability to utilize, instead of level, we can use tolerance, or we can use both. Well, what does that mean? That means that based on the tolerance of my toolpath, will control things like how much smoothing is automatically added to the controller. Or by default, we can utilize what is called level. And the level settings, if I remember correctly, are all based off the fact of stock to leave. So again, as you guys are seeing here, there's options here to set these to get different levels based on, do you want to use the tolerance of the toolpath, or do you want to actually utilize the stock to leave option, which is much more common. So again, if you guys wanted to see that at the end of the day, we're getting a visitor here, guys. Do you want to say hi? Here's the next generation of JIT CAD Cam hanging out, waking up from a nap. She's waving. But again, as you guys, let me scroll up here so you can see this a little bit better. Again, we're in the use smoothing area. Are we going to be basing that off of levels, or are you going to base that off, again, like you're seeing here, operation stock to leave is 0. Again, there's a lot of different ways to set this up. Now, again, I have a video on how to utilize smoothing at the individual toolpath. I keep saying smoothing, you guys, that G187, again, it could be referred to as controller tolerancing. There's a lot of different names for it, but we could associate it to the individual toolpaths as well. This might be something that could help you out at the end of the day, Ash Design, is the ability to force a rough smoothing versus a finished smoothing throughout what you're doing. So I'm going to go ahead and open this back up to you guys. Does anybody else have any other questions out there? JC finally made it on Fusion Friday. Right angle head programming and getting code, or do we need a dedicated post? Well, JC, there's a couple of options here, but yes, I am more than happy to show you guys what you can do with utilizing a right angle head post. Now, full disclosure right now, and what that is going to be is you will need modifications to your post processor. Now, I am going to also tell you guys that in the event that you have our support package, or you're in the world of needing that custom build out in your post, would highly recommend you reach out to us. Now, what I'm going to do is I am going to actually remove the machine here. And the reason for that is with a right angle head, we can't actually do machine simulation. And it's coming. If you guys haven't seen the new Haas machine with the C-axis at the head, there's some really neat things that we're working on here at JIT CAD Cam to get you guys set up to be able to utilize this. But I'm going to use the scenario that we are using a coolant driven and utilizing M19 to actually generate all of our orientational move, right? So again, if I was to go in and I'm just going to say, you know, facing toolpath, let's go ahead and swap out our tool to something that will actually work here. And then I'm going to utilize my tool orientation. So again, as you guys can see, this is nothing more than the normal tool orientation that you would do if you had a 5-axis or a 4-axis machine. A right angle head is going to be treated the same exact way. Now, if I was to go out and post this out, now, again, you guys are going to need a post processor for this. So I'm going to go ahead and jump into my library because I think I have one in here but it is going to be questionable whether or not I can find it. And oh man, I think what's it listed under? I might have to jump over to my other screen in the meantime. Give me one sec here, guys. So let me look through all of my stuff to try to find the last time I had to do this. Give me one sec here. Two more. All right. Should be. Here we go. Right angle heads, baby. So as you're going to see, I'm going to grab a post processor from my library. As you guys can see, this is the first time we've done this. It's been a little bit. I'm going to get my OBS pulled back up so I can at least see chat, answer any questions. I apologize if anybody's been throwing questions out there. But as you're going to see, again, this is where we have built in the M19 offset angle. What that is going to mean is when you hit M19 at your controller, it's going to orientate your spindle, but your right angle head might not be perfect. So we need to compensate that. We also need a distance from the tip of the tool to the center of your spindle. Again, we're accommodating that all here in real time. But if I was to post this out, we are getting a fail, which is always normal. And as you're seeing, is direction is not supported for machine configuration. Now, I'm going to go ahead and take a step back here real quick and make sure that we have everything set up right in our setup. And what I'm going to do is just double verify that we don't need X pointed the same way. And again, in the great world of Fusion, we do this occasionally, as I tell most people. And then we have to come back and figure out what went wrong or what is going to be the use case to actually fix that. So again, we're going to go ahead and post this one more time. We are still getting a fail. As you're seeing, direction is not supported. And we may actually need to use machine definition, which makes me a big fibber at the end of the day. I'm almost certain we do. So let's go ahead and go back to my lovely list. As you guys can see, let's go ahead and grab a generic machine. Try that one more time. Don't think this is going to do it. Nope. As I was thinking, is it is off. Let me go one more time because I think now remembering this specific customer's use case, we were utilizing, nope, that's the GM5AX, but let's give it a look here real quick and see what we can come up with. In the meantime, I do see another question out there. Yep. So I will need to play around with this right angle head post a little bit more and figure out why it's not doing this. I might be able to guesstimate off the top of my head here. But as you guys have seen, actually, you know what we can do? We can go straight back to the original files and double verify everything there, right? So again, let's get back. When in doubt, go back to the original, right? The undo button saves us all. 546. I think I just passed it. And here we go. As you guys can see, if I go ahead and post this out here real quick. Here is the successful posting. Again, guys, you put me on the spot. There's probably something simple I'm forgetting off the top of my head. But as you can see, what is going to be wild about this is in the case of how this one is set up, it is still utilizing 5-axis motions. But you'll notice here, and this is where it gets really fun at the end of the day, is my coordinate system is moving in X, Y, I, J's, and K's instead of Z, right? So again, my Z axis, I've brought my Z axis down to a physical point. And then in the case of this part, just so you guys know, we're actually doing a boring toolpath in from the side. And that's why you're seeing I, J's, and K's. But it's working in the XY plane, which is exactly what needs to happen with a right angle head. But I'm going to go ahead and up the ante and probably break this in some way, shape, or form. Let's swap out to that other post processor. Might have to go open that back up for my library. Also a reason why there's 37 different versions of this post. And as you can see, we got successful code again. Yours truly is probably just messing something up in the programming. But as you're seeing here, is I wanted to show you guys is again, based on what would be considered the 0, or we could say the 12 o'clock position, that our 15.3 is our original offset. So everything you would see in jumping of our code, so we go down here and we rotate that head 90 degrees, we're utilizing the M19 spindle orientation to be able to achieve this. Again, coming down in Z, and then we're moving in that XY functionality. So again, that's how we would do it on our end, JC. If you'd like more information on that, go ahead and send us an email to the info@ email address, and we'd be happy to get you some help there. Pompeii boys. All right, let's see what we got. Can you show us how to get dimensions from a model after importing it? Sure thing. So if you wanted to get dimensions from a model, I would have a couple of questions that I would always ask. Are you just doing what I consider the quoting move, where I can go in and I can inspect utilizing the measure tool, or I as in India? You can go ahead and pick 2 surfaces or multiple surfaces, faces, edges, things of that nature to pick up a very quick reference of a dimension. Now, if you're trying to take this a little bit further than this, is you could always create an actual drawing. Now, not to toot our own horn over here, as you guys see the O scrap item, we have built our own shop tracking tool. And one of the things about that is I personally, when I was on the shop floor, I didn't care too much about a lot of the model dimensions because we are machining to a model nowadays. So I would go ahead and make a drawing to throw in, the raw material bin so that it follows around the job on the shop floor. So again, as you guys are seeing me here, I'm going to go ahead and jump into the good old-fashioned workspace for drawings. Again, we're going to do visible. Let's go ahead and do shaded visible. And then from there, I could do my section views. I wanted to put a 3-dimensional model in the top right corner. As you guys can see, I could then add, like I said, is the ability to just do outside dimensions of the part, right? Now, again, length, width, height, yada, yada, yada. I think you guys are pretty familiar with this. I think we did a little video on this in the past. And from there, you now have a drawing that's associated to the model. Now, for a lot of the machinists out there like myself, you always get a drawing and it's missing something. This gives your team the ability to always go in and call out whatever it is that's missing, or maybe the location of this from an edge. Again, this is nice to have for your guys to be able to go in and do additional things. Now, if I wanted to tolerance stuff at the drawing level, I fully have the ability at any time to click something, throw on the actual tolerance menu, and then I could set, an upper lower tolerance, this is probably one of my favorite ones, is you guys could do that trick that engineers do for some reason, where they may say -5 from the top, and then the lower could be like -10, right? And you could do the good old-fashioned plus or minus pain in the butt type setup. So again, as you guys are seeing, is if you wanted +0, -3, again, what I'm doing here is I'm setting that all up in the software. So that's how you could go about calling out critical dimensions and tolerancing your drawing. Now, there's another way that I would tell people to take a look at. Tim, great to see you out there. Glad to have you. Also, can't wait to see you Monday. I'm actually making my way down to Florida, guys. Let me go ahead and get that pulled up for you. Based on all of the training and stuff we have going on over the next month, we are taking off Sunday and making our way down to Florida over the next week. But we are going to stop off and see Tim and his crew for the first time over in Wisconsin. So let's go ahead and go back to our part. Now, in my opinion, what I would do with something like this is jumping over to the manufacturer side of things is if I was looking to move away from paper and want to start tracking documentation digitally, this is where I could do something like the inspection side of Fusion and create what's called manual inspections. What this allows you to do, as you guys kind of saw on the drawing side of things, is I can set up different dimensions for somebody to measure the parts. As you're seeing, once again, I could call out my holes, I could even call out my whole locations from edges, things like that at the end of the day to make your life much easier, much better, and much simpler. So as you guys are seeing me do this, I've now recorded 3 locations for dimensioning. I could go ahead and right click on manual inspect. I could record my manual inspect. Don't worry guys, if I'm moving too fast for you, I've got videos on our YouTube channel about this by all means. But again, if you have the fancy Bluetooth or the USB plugged in calipers / micro height, is when you measure something, if it is out of tolerance, it's going to tell you in real time. As you guys can see, it's showing me nominally what that feature is supposed to be. And then from there, either a deviation and or error. And I can work through this. So again, let's say, because we all know how machinists love to chase perfection, we're at 2/10 out on that guy. And then this hole could have been a go, no go gauge. Maybe you're using dowel pins, things like that. Again, pass or fail. So as you guys have seen, I've now generated an inspection report to be utilized for my own documentation or to even send it off to my customer at the end of the day. So again, I could look at my results based on the inspection. I could turn around and actually generate an inspection report, save this, file it away in the cloud, not eat up a bunch of hard drive space. One pro tip here that I would have for you guys, what I would do if I was you though, is let's say, for example, today is 10/24. Let's just say I'm going to use EMB, which is my initials. And I could type in 10/24, right? That's who did it. That's when I did it. I could even leave comments to people on my team. I don't know if I have anybody on here. I don't have anybody on my team, but you could nominate so-and-so, first article, checks good, right? Don't hassle me in chat in the comments. I know one of those we typed in was completely fake. This is a hypothetical scenario. But as you guys are seeing, this is the fun inside of Fusion to digitalize your process, making life much easier. Again, your saw operator, if you had outside dimensions pulled on here, could very easily see the outside dimensions of his part. So again, I hope that helps you out. At the end of the day, Pompey, let me know. Again, that's 3 different scenarios between inspecting with the measuring tool, creating a drawing, or lastly, generating manual inspect inside of the inspection tab. So, Tim, great question. As you're going to see, we're going to go ahead and jump over, but real quick, Brandon from Zeiss Products. Brandon, I saw your message before I jumped on stream. I understand you're having problems. Brandon, give me the okay so I could show the part, and I'll go ahead and talk about it, but I'm going to keep my mouth shut in the meantime. For the record, guys, they approached us with a problem. We've yet to solve it. We will solve it. Don't worry. But I don't want you guys to think that I'm the problem here. So let's go ahead and pivot over to Tim's. So based on the information that Tim is asking, is there auto dimensioning inside of Fusion? There actually 100% is at the end of the day. So as you guys can see here on this part, I have the option to auto dimension. However, if I rinse and repeat the process, so I'm going back to my original part, drawing from design, I can actually say automatic. And as you guys are seeing, this is going to, based on your assemblies, again, you could do all the levels. But as you're going to see me do here, I'm going to go ahead and hit OK. And then this is automatically going to go through and set everything up. Again, give me a sec here. People are out there buying beers. Love to see it. Not mad about it at all. And as you're seeing, I think that is on me. Let's do this one more time. Actually, I did touch the other screen while I was swiping things away. Automatic dimensions. Here we go. This time it should work. If not, we'll just open the... Obviously, it did work. I missed the menu. As you're seeing, we've actually already did this once. Again, the power of the cloud, right? What you guys are going to notice, this is going to open up our design. It's auto-placed our part. It's auto-placed dimensions on there. Now, this was something that threw me off at first. So if any of you guys out there, just want to point this out. Any of you guys have ever taken our Fusion boot camp, we have drawings we provide, and I tell everybody the same. When I made the parts, it was a late night on the weekend, thanks to all these spheres that get bought, but I utilized AI dimensioning, and I never realized that you can scale up or scale down how many dimensions are getting called out. Full disclaimer, right? So again, as you guys are seeing, is based on the information here, is I could scale up or scale down as much as I want out of the dimensioning. Now, after the fact, you guys have the ability to change this and edit as much as you want. So as you guys are seeing, is it's auto place dimensions. I may want to move them. I may want to eliminate things like 135 degrees here. All I did was click the part and hit delete. I can also go to any of these parts at any time, change the way they look, and of course, manipulate this further from here. So again, I can bring this guy over here. Maybe I want this dimension to be moved up. All of this is usable at the end of the day. So, Tim, I hope that helps you out. As you guys can see, again, automatic dimensioning, automatic drawing generation is possible. It might be a little messy. You might want to manipulate a few things, but if it was me, again, this is a good example here. Notice how it's calling out a area that is cut between the two. Very easy for me to go back and just say, you know what? I really don't need to call any of that out. And I probably could have scaled up or scaled down the actual auto dimensioning to get there. So again, what you guys see there on that part is this little pocket right here is, again, I drew this part to test a right angle head to get our tool orientation set up and things of that nature. So as you can see, so we're not going to get to see that part. Again, that's the fun of working with us at CAD Cam. We keep everybody's stuff safe. We don't share what we can't share. As you guys saw, sharing this part is a generic part. There's nothing here to share to you guys to like tell you this or a right angle head post. But I'm going to go ahead and jump over here real quick to make sure that we're not getting any tickets in yet. We do have about 8-ish minutes left here before I am going to jump over to the Too Tall Toby channel. And I just got a notification. Ash, I think your email bounced, but everything went through, just for the record, if you're still here. So, again, getting back over to OBS real quick, guys. Do you have any other questions outside of there? Oh, here we go. Is there any way to use a chamfer mill to mill a large chamfer in multiple steps? Let's go ahead. Actually, there is, and I'm trying to remember. This is the real fun of this part. All right. So, you guys got to bear with me. We got 8 minutes. We're going to speed run this. Yes, 100%. We do tons of part maker stuff in-house. So again, based on that information, I would tell you, go ahead and email us over and we could take a look at whatever you have with part maker. But on this part in particular, let's get back to the manufacturer side of things. I'm going to go ahead and delete all this stuff out here. And we're just going to do a brand new setup. Z-axis up. And as you guys can see, I have this big, lovely 45-degree angle face. But maybe I don't have a 5-axis machine. Maybe I don't want to do this in multiple setups because this is just a corner relief for some reason, right? So if I go in, and if I'm thinking about this right, this is going to be 1 in a million that I get this right off the rip. As you guys are going to see, I believe you actually have to do this by building out a chamfer mill. Now, I say that, but I'm probably going to be mistaken here in a minute. As you guys can see, I have a 1/2-inch chamfer mill. Maybe there's a 50 thou tip flat. And just like that, we have our tool, right? Now, from that, I need geometry to work off of. Again, holding my Alt key here. Oh, looks like we bugged out. We're going to do an open contour, and let's go ahead and extend that a 1/2 inch on both ends. Now, as you guys know, I'm a huge fan of get a toolpath on your part before you get too far in the weeds, right? So as you guys are going to do, I'm going to go back and I'm going to edit that actual toolpath, and I'm going to go to the passes tab, and we are very possibly getting lucky here because I believe, oh, where is it? There's something about angle, and I'm missing it. And it would be because of multiple depths. So let's go ahead and turn off chamfer. We have multiple passes. but we do not have step over. We need to step down. So this is where I think I'm backwards on the system. So I'm going to go ahead and jump up to my tool, and we're going to go ahead and select a different tool here real quick. Let's go back in there because this is, I'm around. We're going to utilize, oh, what is it going to be? I think we're going to go for it with the old spot drill. Actually, I think it's countersink. It may be countersink. Let's try this. So again, as you guys are going to see, we have multiple depths now. So I'm defining my tool with multiple depths. And then what I would do from there, again, this is where you need wall taper. So there it was. Took 2 tries. 2 tries. I didn't have to get the hat trick. Let's get back in there and see what it doesn't like. So again, let's go ahead and kick off multiple depths real quick and get a tool path. As you guys are seeing, wrong tool definition. But let's do this one more time here. So we're going to go back, select a different tool. Again, I think I have a video on this. And it's funny because right before I did it, I actually set everything up to be utilized so that I didn't mess this up in the middle of all of the stuff that we have going on. So again, wrong tool definition. I'm going to go ahead and edit this tool here real quick because I know it's not a 90-degree countersink. And we'll go ahead and accept that. How did I change my Fusion to dark mode? No problem. So if you actually go up and hit your preferences, and from there in the general area, as you guys will see, you have a theme up here at the top. You can go ahead and match device theme. In this case, my device is on dark mode, or you can force dark blue, which would also give you that very similar output. Let's do this a few more times. Why not, right? We're going to go ahead and go 2D contour one more time. I don't think it would be a face mill, but a part of me really feels like it might, or possibly a dovetail mill. So we're going to go ahead and do a tapered end mill as well. Believe we got to be, nope, it's going to be 45. And then again, one more go with this. Here's my edge. Lastly, we're going to go ahead and go with multiple depths, 45 degrees. And there it is. So it took me 4 tries, but we got there, right? And how I did that is I utilized a tool, which was a tapered end mill, and then basically lied to the system. So again, Autodesk, I know you guys watch my content. Please fix this. Why can't we taper down a wall with a spot drill or a chamfer mill? Why does it have to be such a pain to go ahead and work around? So with that, though, we are still 2 minutes out. I'm going to go ahead and check the ticket system one more time. I don't see anything. I'm going to go ahead and leave. I think we're good. I think it is time for, as you guys know it, your chance to ask one more question. But I am going to jump over to the good old-fashioned how to support this channel. As you guys know, it's not what you know, it's who you know. And we love to bring you this free session on the weekends, or not on the weekends, on Friday afternoon, give you the opportunity to ask the questions that you can't find answers to, or you've just been scratching your head because you've never thought to think like Fusion Phil. So with that, I will leave you guys to it. Have a great rest of your weekend. Have a great rest of your day. Hopefully you're getting off early, possibly. And if you're working Saturday, we know you're getting overtime. But I am going to jump over to the Too Tall Toby channel where we are doing the CAD versus CAD, which technically there is 2 Fusion runners right now in the semifinals, and it is going to get crazy. So guys, once again, have a great rest of your week, and I look forward to seeing you guys probably next Friday. I think I will stream live again next Friday, even though I'll be on the road. So see you guys. Have a good one.